All right, so on Thursday, we did this set of notes and looked at some transformations. And remember that we all know that x is a liar, but x is a liar inside of the function. Once it comes out of the function, whether it's in an ordered pair or in words or whatever, then the lies are over. Okay? So we got to know when he's lying and when he's not. And really, whether he's lying or not, it's not even going to matter for the first part of what we do here. We look at example 6. It says the table above gives values for function p. It selected values of x. Now, it's very important. A lot of what we've done so far, if we have the table that's p, we're just talking about p. But this is p of x. It tells me that. But then we're also talking about h of x. So you have to make sure you know when you're looking at which different ones there are. Okay? And I want to find the following values. So p of x is defined by these points, or that's at least some of them. And then they've given me an equation for h. I don't need to overthink it. I don't need to write out my transformations. All I have to do is understand function notation. And if I'm going to substitute in -1 here for x, I substitute in -1 everywhere I see an x. So that will equal 3 times p of 2 times -1 minus 1. And your first step when you're substituting should always be just substitute it in, 0 work. You just substitute it in and that's it. Sometimes that's worth a point on free response questions. And then if you royally mess it up from here, okay, you might not get the other point, but at least you got something, right? So don't try and do a whole bunch of stuff at once. And then if you skip steps or whatever, that's fine. But that's equal to 3 times p of, all right, 2 times -1 is -2 minus 1. Then I need p of -2. Where am I going to find that? In the chart, right here. When x is -2, p is 1. So this is 3 times 1 minus 1. So h of -1 equals 2. And that's it. So in that situation, don't overthink it. We're done. The transformations took care of themselves. Technically, for this question, you don't even have to understand the transformations, right? Because it just did it all for you, right? So there's going to be lots of different ways that we apply this stuff. Okay? You have questions? You got that? Okay. All right. So then for h of 2, I'm just going to substitute 2 in there. It's going to be 3 times p of 2 times 2 minus 1. So then that is 3 times p of 4 minus 1. What is p of 4? 3. So it's going to be 3 times 3 minus 1. So h of 2 equals 8. Okay. We all good with that? Awesome. All right. You do C. I got -4. Did you get -4? If you did not get -4, did you figure out why you should have gotten -4? Okay. All right. Any questions at this point? Okay. Super simple application of that, right? All right, now let's look at example 7. So it tells me that the function g is constructed by applying 3 transformations to the graph of f. We have a horizontal dilation by a factor of 3, vertical dilation by a factor of 4, vertical translation by -7, and then it gives me this little g of x here. So if you remember on the first day we talked about this, I said I could teach you using A, B, and C and D. I could use A, B, H, and K. We could use P, Q, R, and S. Even if I had chosen to do A, B, C, and D, that's not where I would have put C, because that's not where anybody puts C. So I don't really understand why College Board does stuff like this, but they did. But remember, what I also said was it really doesn't matter what the letters are. You just have to know where they are and what they do. So as long as we can build it, they will always give you a generic one to look at. So look at it, right? Even if A is not where you're used to A being or whatever, you go by whatever they gave you on that specific question, okay? I don't know why we can't be consistent, but nobody asked me. So what I am going to do is I'm going to start by writing an equation for g of x. I'm going to look at, they've given me 3 transformations. I know if it says horizontal, it affects x. If it says vertical, it affects y. The only one I really have to think about is the reflections so that I don't get them backwards, right? So I know if it affects x, then that means it happens inside the function part, inside of here, right here, right? And if I have a horizontal dilation by a factor of 3, what am I multiplying by? What do I multiply by? 1/3, because x is a liar. So this would be f of 1/3 times x. Then I have a vertical dilation by 4. What am I multiplying by? 4. And that vertical dilation comes out front, right? And then I have a vertical translation by -7. That makes this -7. Okay, so you see how you build that? Now, they didn't ask me to write an equation. I needed to, because you don't want to try and do this without it. That's where we make really careless, ridiculous errors. Now that I have that, what I want is A, B, and C, and I know exactly where to pull them from because of this. A is 4, B is 1/3, C is -7. Okay. What questions do you have? Anything? Good? All right. Let's look at example 8. So the table above, h of x, this is k of x, right? Gives me my little generic. It's showing me that k is a transformation of h, and a, b, and c are positive constants. In the xy plane, anytime it says that, don't let that get you all messed. That just means the place where you've been graphing everything, nothing new and different. The graph of k is constructed by applying 3 transformations. So again, we have a horizontal dilation, a vertical dilation, and a vertical translation. So I'm going to mark them for myself. The horizontal is x, vertical is y, vertical is y. So that I can do k of x. And go ahead and see if you can write your equation. That's what I got. See if you agree with me. My horizontal dilation is by a factor of 1/2, which means I'm really multiplying by 2. Then my vertical dilation, and then my vertical translation. Are we all good on that? Okay. So then what it's really asking me for is k of -6. So k of -6, I'm just going to substitute it into that. That's 3 times h of 2 times -6 plus 1. Then just like we did at the top, that'll give me 3 times h of -12 plus 1. What is h of -12? 1. So I get 3 times 1 plus 1. So k of -6 equals 4. Okay. I didn't have to graph it. I didn't have to do anything crazy. Questions? Anything? Okie dokie. Example 9. The function p is given by this. So there's p of x. The graph of R is the image of P after a horizontal translation of 4. And then here's my little generic form that I need to find A and B. I only have one transformation, and that's a horizontal transformation. That affects X. That means I have to apply that to X before I multiply by 3. So my R of X will be 3 times X something, right? If I have a horizontal translation of 4, what's going to go in there with the X? Negative 4. I'm going to subtract 4. Yes. It's a translation, and it's a positive 4, so X is a liar. We make it a negative 4, and then still just this minus 2. Now, this is a perfectly fine equation. I mean, it's gonna graph the same thing as if we do something else, but I need it in this form so that I can get A and B. So I just distribute. It's no big deal. This gives me 3x minus 12 minus 2. So R of X is equal to 3x minus 14. Then again, they gave me the generic, and this time my vertical shift is B instead of C like it was on the others, but that doesn't matter. I just pull them right out of my equation. A is equal to 3, B is equal to negative 14. Questions? Anything? We all good? All right, then grab your other sheet of paper. This is also going on page 40 when we're done. Okay. So it tells me that the graph of F is shown above. It is labeled as F. Anytime I need something for F, I can get it from the graph. If it's G or anything else, I got to have other information. So the first thing that I'm asked for is just the domain and range of F. That's an Algebra 1 question. That's easy. I just get it straight from the graph, right? Where does my domain start? Negative 5. And it goes to 5. Good. Do I include them both? Yes, I do. My range starts where? Negative 3. Negative 3 and goes to 3. Do I include them? Yes. Negative 3 are Y values on here that I actually use, so they do get included. Okay? That's just straight up my domain and range. Okay, so now we're asked for the domain and range of G, which is different, right? And they give me G of X right here. Before we get that far, we are going to write down our new ordered pairs. Remember this mapping thing that we did here? So when I look at this, I have 3 transformations. How many of them affect X? 1 of them. And that 1 means I have what? A horizontal translation of 1. And so even though it looks like minus 1, when you actually do it, you're adding 1. So this becomes X plus 1. X is a liar inside of the function. Outside of the function, he is not. Okay? Then, since that F of X minus 1 is like my Y value, the 2 and the 3 affect Y. So that's just going to be 2 times Y plus 3. This is my X and Y for F. This is my X and Y for G. To get the domain and range, it is super easy as long as you don't also make a mistake that is super easy to make. Is this XY? No, this is XX and YY, right? So I don't do this to the negative 5 and this to the positive 5 because that makes no sense, right? I do, for every single X value that exists, we're going to add 1 to it. So my new domain, negative 5 plus 1 is negative 4, and 5 plus 1 is 6. Range is YY, so I do this to it. Take that negative 3 and double it and get negative 6. Add 3, and that gives me negative 3. Then I have 3, and I double it, and I add 3, and that gives me 9. And there's my answers. What questions we got? Ask me a question. We good? I'll take that as yes. Okay. So then we have this ordered pair, 4, 2 on F. Okay, it's on that graph, but I don't even care. I don't need to see it. And it transforms into what from G? This time, this is XY. And that's why I wrote out this. I take that X value and I add 1 and it becomes 5. I take the Y value, I double it and add 3 and I get 7. Okay, just coming straight from this right here. Okay, we good with that? Questions? All right. So then I need G of 0. Well, G of X is defined for me right here. So G of 0, just like we did on the front of the, or the top of the first thing we did, that'd be 2 times F of 0 minus 1 plus 3. First step, 0 work, substitute it in. Then 2 times F of negative 1 plus 3. How do I figure out what F of negative 1 is? I'll go up here, right? So I got negative 1. This ordered pair is negative 1, 3. So that means that F of negative 1 equals 3. Y'all agree with that? Because we're going to come back to something like that in a minute, and you're going to think it's blowing your mind, but hopefully you can make sense of that from an ordered pair. So F of negative 1 is 3, so that gives me 2 times 3 plus 3, and that's 9. Okay. Questions? Nothing? All right. D says, how many solutions does this equation have? Does it ask me what the solutions are? No. It says, how many are there? It says to explain your reasoning. On this one, your work really is your reasoning. So I probably could have left that off. But all right. So I have G of X. G of X is defined right here. Okay. Is this 0 my input or output? Output. So I'm not substituting in 0 for X. You understand that? Because that's what I just did here. And this is not the same thing. It's my output. So I'm going to take the G of X they gave me, which is 2 times F of X minus 1 plus 3. That's what they defined as G of X for me. And I'm going to set that equal to 0. Now I'm going to isolate this F of X minus 1. Same algebra steps you've been doing forever. First thing I'm going to do is move the 3. So I'm going to get 2 times F of X minus 1 equals negative 3. Right? What would be the next thing I do? Divide by 2. So this will give me F of X minus 1 equals negative 3 halves. Now here's what I can't do. I can't add 1 to both sides to try and get X by itself because that makes absolutely no sense. All right? But I isolated that thing. So if I put it in X, if I substitute it in X and I subtract 1 and then I evaluate that on my graph, I will get negative 3 halves. So this is telling me somewhere on my F graph, I have an output of negative 3 halves. It's not asking me exactly what the X value is, so I really don't care at this point. But if I go up here, negative 3 halves is negative 1.5, right? That's right here. How many times is this graph give you a value of negative 1/2? Once, just right here. If it was positive 1.5, then it would be 4, right? But that's not 4, it's down here, so it's just exactly 1. I don't even care what X really is. I can just say, bless you, that G of X equals 0 exactly once. Or exactly 1, exactly once, whatever. And again, you're really showing your work is how you figured it out. That's your reasoning here. That's not really a good way to ask that question. I should have taken that off. Okay. What questions do you have? We good with that? Got to be able to write stuff in function notation and not be afraid of the notation for sure. Okay, then we are asked on what intervals is g of x increasing? Well, I can look up here and I can tell you where f of x is increasing, right? Because I have a graph. I don't want to have to graph g of x. I could, but I don't want to. And you don't want to, you don't have time for all that stuff. But what I do know is if I figure out where f is increasing, so f is increasing here and here, and then I do have to have some idea of what's happening to my graph. This right here tells me that the whole graph gets shifted over to the right one, and then then vertically it gets stretched and moved up 3, right? When we write about where things are increasing or decreasing or concave up, concave down, whatever, we're writing about intervals of the domain. So if I can figure out the intervals of the domain where f is increasing, then I'm just going to apply that to it just like I did for the actual domain. Does that make sense to you? So f is increasing from -4 to -1 and from 1 to 4. Now I know they're asking us about g, but this statement right here is very important because this is what it's leading us into. Our explanations or our answers have to be based on f. They have to be based on what they gave us. They gave us f and some information about g, and that's how we figure it all out. So I can't just say what's happening with g. I have to talk about it through the lens of f. So basically you just have to kind of say like how you know it. So even though it's asking me for g, I start off this way. And I say that f is increasing on, and then I write down those intervals. What was that, from -4 to -1 and 1 to 4? Okay. And then because I know that, so then therefore g is increasing on, and again you ask yourself, are these xx, xy, xyy? What are these? xx. This is xx, xx. Okay, because they look like ordered pairs. Don't go doing weird things. And all I do to x is what? Add 1. So it'll be -3, 0, and -3, 0, and 2, 5. Okay. What questions do you have? Anything? Good? All right, flip it over. This is still f, even though it doesn't say it. So this is still f. Let's write down our domain and range for f that we already found. It was going from -5 to 5. And our range was going from -3 to 3, because it's the same graph that was on the other side. I just wanted us to have more room to write. So what I want you to start off with is writing what is happening with your ordered pairs. This is f, and then I want you to write what is happening with h based on the transformations. Okay. Because I only have one transformation that affects x, and he's a liar, so I take him out so he's not lying, and then basically that's just what's happening with y there. Okay. We good on that? Whose is this? Is this yours? Are we good on this and how to get it? Okay, because then we're going to use this for everything else. All right, so then our domain and range for h, our domain, what are we going to do with these two numbers? Subtract 3. So this is -8, 2. And then for both of these, we're going to multiply them by -2 and subtract 1. So -3 times a -2 is a +6, minus 1 is 5. Then -2 times 3 is -6, minus 1 is -7. Okay. Now, is what we wrote down, does it make sense? No, why not? Because it's backwards. Yeah. Has to be in order. I should have asked you on the first one too, but I forgot every single class period. But the first one was fine. The reason that this is not okay is because we multiply by a negative. This is least to greatest. It's fine. This is not least to greatest. We didn't do anything wrong. We just have to recognize that and then rewrite it as -7.5 and just mark that one out. Okay. That happens anytime you multiply by a negative because it's reflecting. Okay. So what is happening here to f? We would take this whole function, it's going to shift to the left 3. And then it's going to reflect in the x-axis, get stretched and move down 1, right? And so that reflection is important because certain things will change depending on whether or not we've reflected in x or y or whatever. This asks for, when is h concave up? Do we want to look for when f is concave up? No, because we reflected in the x-axis, right? So we really need to find when f is what? Concave down, right? So you do have to at least think about your transformations, and because of that reflection, that changes concave up to down and vice versa, right? All right, so then the other thing is, I've told you a few times, you're not going to have to find your points of inflection. You don't have to assume anything. They will be told to you. And I forgot to tell them to you on here, so I'm just going to tell you. So the reason you know exactly where they are is because I'm telling you right now. And to be honest with you, I don't even know for sure that this is exactly where they are because I didn't do the math, but they're whole numbers and it'll work for this question. It really doesn't matter. Okay. All right, so I want when h is concave up, so I need when f is concave down. So that's there to there, from -2 to 0, and then 3 to 5. So I'm going to answer it the same way, through the lens of f. And I'll say f is concave down on, where was that? -2 to 0 and 3 to 5. So we know that by looking at the graph. Therefore, since we know things about our transformations, G is concave up on, and what do we do with these x values? Subtract 3. All we're doing is subtracting 3. So it's -5, -3, and 0, 2. Oh, it's H. What did I do? Oh, shoot. It totally is H and not G. Thank you. Yeah, we don't know. Yeah, that's not G. That's H. You got to call them by the right names. Thank you very much. H. I even circled it. Still didn't help me. And I've done it 3 times today. So, all right. Questions? We good? Good catch. All right. So now the next thing asks me for when H is increasing. So am I going to look for when F is increasing? No, because of the reflection, I want when F is what? Decreasing. And F is decreasing here, and here, and here. Okay, the 3 squiggly pink parts. So then I'm going to say that F is decreasing on -5 to -4, -1 to 1, and 4 to 5. Therefore, H is increasing on, and what do I do with all of those values? No. Subtract 3. These are all intervals of the domain. So this is -8, -7, -4, -2, and 1, 2. Okay, everybody with me? We good? Any questions? Okay. Now this one says, find any, actually I have to find the solutions this time, not how many, I have to find them when h of x equals 5. So my h of x that they defined for me was -2 times f of x plus 3 minus 1, and I'm going to set that equal to 5. Okay, I am not substituting in 5 because 5 is not the x value. All right, so now I'm going to just isolate this function part. So I'm going to start by adding 1. So I get negative 2 times f of x plus 3 equals 6. Then I divide. So I get f of x plus 3 equals negative 3. Any questions at this point? Okay. So just like before, I put in some value for x, then I'm going to add 3, and then I'm going to have an output value of negative 3. So my f function, that graph up there, I'm going to go look for an output value of negative 3. Here is an output value of negative 3, and there's only one of them. All right? This ordered pair is negative 3, negative 4. No, it is not. It is not that at all. Sorry about that. It is negative 4, negative 3. That sounds better, right? Okay. So, do you agree then that f of negative 4 equals 3? Negative 3. Just like y'all were fine with it over here. You were fine with it when we came up with this ordered pair. And I said that ordered pair is negative 1, 3. That means f of negative 1 equals 3. We all said yes, right? Then nobody wants to say yes on this other one. X is your input, y is your output. So if that's true here, that's true here. If my ordered pair is negative 4, negative 3, when my input is negative 4, my output is negative 3. Okay? We good with that? So then this is a true statement. We all agree with that. Now, hopefully I can write it correctly down here because I keep writing the wrong numbers. Okay, so I'm going to write it down here. F of negative 4 equals negative 3. I'm just rewriting what was up there so that we can see it. We agree that this is a true statement, yes? And we agree that this is a true statement from what they gave us and what we did, yes? Okay, so if these are both true, then what little equation could I set up to figure out what the value of x is? What would this have to be equal to? Negative 4, right? Don't these two things have to be the same if the output is negative 3? So then x plus 3 equals negative 4, and x equals negative 7. That's the x value for when h of x is equal to 5. So that means h of negative 7 equals 5 is what we're looking for. Okay? You're not going to be able to wrap your mind around that stuff if you're not actually writing these things down. And some of y'all are so stubborn about writing things down. Yes, ma'am. Oh, okay. Glad I could help. All right. What else? Anything else? Questions? Do I need to repeat any of that? We good? I know this one's a little weird, but just don't be making up math like trying to subtract the 3 out of here or something like that. Write down what you know, see what matches, okay? Questions? All right, good deal.